Hey guys, welcome to the second day of Unit 0. We're going to talk a little bit about scientific inquiry, just kind of questioning and problem solving. You may have also thought of the term scientific method. We'll talk about that as well. The first thing I'm going to have you do, open up a PowerPoint that I've listed with this video. The first slide is going to be a video, and I want you to write your answers down in your packet, and then also put the answers in the link that is put for you right here. So go ahead, take a few minutes to watch the Mythbusters video, and then come on back to the rest. Alright, so what is scientific inquiry? It is a process of investigation that leads to producing more knowledge. So again, it's that question and figuring out the answer. One of the things you have to do is make careful observations and accurate ones, and then create explanations that help make sense of these observations. So that's something that kind of leads you to a hypothesis. All right. It helps develop an understanding of the world around us too. All of the things that you're learning, especially through math and science and history, a lot of it is through scientific inquiry. All right, this was part of your warm-up. Theory versus law, what is the difference? Theory relies on an inference. So inference means that you're guessing something about it. It's not directly stated. The theory also answers the how of a question, to where law, like a law of gravity, works for specific conditions, and it answers the what happens. So this is what happens, and the theory is how. What they both do in conjunction together is they're both based on evidence. So it's not just guessing. We've already run our experiments at this time. And it changes with new evidence. It's one big thing about science. Even from when I was in high school 20 years ago to now, science has changed a lot. Pluto used to be a planet. Based on new evidence, it no longer is. It doesn't have a defined orbit. So over time, these things change, and we can't always hold on to the old stuff as new changes come out. So here's your traditional scientific method. It's broke down as a process. You begin with that basic question, something like, how is acid rain affecting plants? You do your background research on it. You find out it has a different pH and that plants have different pH tolerances. Based off of your research, you construct that hypothesis. Yes, most people put it in an if-then-because statement, but the biggest thing about the hypothesis, remember, is that it needs to be testable. Right? Once you have that testable hypothesis, that's when you get the materials you need, put together a method, and you test with an experiment, which would have your control groups, your experimental groups, we'll talk about in a moment, and find out the data. So once you have data, you're going to analyze those results. You're going to draw conclusions on it. If your hypothesis is true, you get to report them. It goes through things like peer review. You can get published, things like that. If your hypothesis didn't work or is partially true, you can still report your results because bad results are still good information. And then you can also adjust your hypothesis with your newfound knowledge of what isn't working or what's only partially working, and try it all over again and refine that process. All right. So like I said earlier, a hypothesis is a tentative, testable question for something you have seen or think will happen in a given situation. So I think if I don't give my flowers water, they might die, right? Or dry out and die. It answers the question. Can we test it? Yes, I can have a few different vases of water set up with flowers in them, and then I can also have a few different vases with no water and see what happens to my flowers. Can you predict and explain that potential outcome? So that involves some of the explanation part. How can you know that these flowers are going to wilt? Why are they wilting? All right, good or bad? So These are 4 hypotheses. I want you to, they're listed in your note packet. I want you to tell me if they're good or bad and why. So if you have to, jump back to the previous slide or the previous part of this video and look at what a hypothesis requires. So when there is less oxygen in the water, rainbow trout suffer more life. What do you think? Okay, less oxygen in the water, that's something we can test. We can create different environments with different amounts of dissolved oxygen. What might be hard to test is that rainbow trout suffer more life, but given the right testing and unlimited funding, probably you could actually test that. So it is something that would be a good hypothesis. The only downside to that one is there's no explanation in there. There's no hint to what you believe is going to happen. So what I'd like you to do is answers 2, 3, and 4 in your packet. All right, so if you need to pause this video, do so right now, and then we're going to move on. All right, the next part of that wasn't in that picture of the scientific process, but is still extremely important, is a method. And a method is just the steps to complete an experiment. They have to be very specific. So think about how you would tell someone to make a pancake or a waffle that has never made one before. You can't just say, oh yeah, just add some water. How much? Is it cold water? Is it hot water? What am I adding it to? Do I need it in a bowl? Do I need it ready to go in the oven? And what other utensils are you going to need? So think about that. Your packet does ask for you to give me instructions, I believe, on how to make a peanut butter and jelly sandwich. Pretend I have never made one before, even though I probably eat them almost every day. And be as specific as possible. Have somebody act it out. Call up a friend and tell them to act it out if you're having trouble figuring out a very specific method. It should not be short. There's a reason that box is very big. Don't forget to include any measurements or amounts. So when you tell somebody put peanut butter on one side of the bread, well, is it a gallon of peanut butter that goes on one side? A teaspoon of peanut butter? Try and figure that out and see what you can come up with. All right, dependent variables and groups are really, really important. So our first couple is variables. Our independent variable is the variable that gets changed in an experiment. It goes on the x-axis, so the one that's down here on the bottom, it's horizontal. It's also called a treatment. What are we treating? Dependent variable is the variable that gets measured in the experiment. It goes on the y-axis, the one that goes up and down. So it's what gets measured. It's your results. It's your respondent variable or response. There's 2 different kinds of groups. We have our experimental groups. So you have different amounts of treatment applied. So maybe going back to the flowers dying without water, let's give them maybe only some of them a cup of water, some of them 2 cups of water, some of them 3 cups of water, and then see if the amounts make any difference for how long it takes them to wilt and die. The control group would be the no treatment at all. So that would be your group with no water. The constants are the things that stay the same throughout the entire experiment. So you're not giving one plant distilled water and one plant tap water, right? They're getting the same kind of water. They're also getting the same amount of sunlight. We know sun affects the growth of plants. The temperature of the room, so you would store them all in the same room. You're not going to put some outside and some inside, things like that. So things that stay constant for everything that's not being tested. Over to the right here, you're going to see dry mix. It's kind of a little acronym to help you remember what goes where when you're graphing results. So dry is your dependent variable. It's also called your response variable because it's a response to your experiment. And remember, it goes on that y-axis. Your mix is your manipulated independent variable, and it goes on your x. So that's kind of a little memory trick. All right. You can pause and practice on these. You have 5 questions of variable practice. Tell me what is the independent versus the dependent variable. I'll do the first one with you. If plants are watered, then growth height of that plant will increase. In this case, our independent variable, the thing that is changing or that we're testing, is going to be the water. The number one, your manipulated independent variable should say water or amount of water. Your responding dependent variable, what are we measuring? We're measuring the growth or the height that the plant increases by. All right, so that would be your growth. Now we don't know if it's feet, inches, whatever it may be. All right, so do 2 through 5 on your own and then come on back to this video. All right, so here's a scenario. I want to see what you can find in your note packet. It lists different parts of the experiment out, like your hypothesis, your independent, dependent variable. I want you to read this and tell me what is what. I think the only thing I added on there to trip you up maybe a little bit is trials. And trials would talk about, where's my cursor? 25 plants per flat. So that means we have 25 trials of each one going on, because sometimes the plant just might not grow no matter what we do to it. No matter how much compost or water or food it gets given, light, it still might be a dud. So that's why we do trials. So go ahead and pause this video and see what you can get. We'll go over it tomorrow. The last thing I want to talk about is perfect results. When talking about the scientific method, sometimes you don't get good data or you don't get the results you were expecting. That's okay. And totally normal, actually. Probably happens more often to get bad results or unexpected ones than stuff that you actually were looking for. Some of the greatest inventions have been accidents. Your microwave that you get to cook your pizza rolls in was accidentally found when a guy melted a chocolate bar in his pocket trying to work on radar systems for the military. X-rays was found on accident as well. Velcro, sweet and low sugar was found while working on coal tar, which is absolutely disgusting. Things like penicillin and Play-Doh. Go ahead and read the article. Click on the link in your PowerPoint that you've been given. This also is your DOL. So there are questions in the DOL related to this. All right, see you tomorrow.